mentioned in the introduction, this special session is entitled AI Pair, AI and Big Data Applications Towards Person-Centered E-Health, Personalized Recommendations and Improved Quality of Life. It is held and is organized in the context of the iHealth project. This is an EU-funded Horizon 2020 project. Is related with personalized health monitoring and decision support based on artificial intelligence and holistic health records. In the context of this workshop special session, is also organized by the Department of Digital Systems, University of Piraeus Research Center, where me, George Manias, and also my supervisor, Professor Demosthenis Kyriazis, are chairing this session. So in this context, we will present 7 manuscripts, highly related with applications and advancement and state-of-the-art approaches and techniques that can be utilized in order to enhance the insights and the analyticals that can be derived from the process of healthcare-related data, both primary but also secondary data. So, in the context of this special session, the manuscripts, the papers that will be presented is at first the Advanced Notebook, a tool for enhanced management of machine learning models and procedures in the healthcare domain that will be presented from Irina Nicolae. We have the artificial intelligence implementation for development of socially significant disease prediction and risk mitigation monitoring as concerns especially the patient's perspective that will be presented by Professor Rostislav Konstantinov, as also the 2 other papers, the implementation of artificial intelligence for risk prediction and personalized preventive and treatment program as concerns the hospital medical specialist perspective and the primary healthcare providers' attitudes towards artificial intelligence and information communication technologies. Implementation is highly focused and related into the pancreatic cancer risk prediction, prevention, and early diagnosis, where also Professor Rostislav Konstantinov will present. Then we have the presentation from Nina Rensic as concerns the Smart Change EU-funded project and more specifically AI-based long-term health risk evaluation for driving behavior change strategies in children and youth. Next, we have 2 presentations from the Department of Digital Systems, the University of Piraeus, an evaluation of machine learning models coupled with powerful big data techniques on the case of pancreatic cancer that will be presented by my colleague Eleftheria Kouremenu, and also an optimized pipeline for the processing of healthcare data towards the creation of holistic health records, which is also one of the key outcomes of the iHealth project as mentioned before. So now I give the floor to Irina from Siemens, Romania, in order to present the Advanced Notebook, a tool for enhanced management of machine learning models and procedures in the healthcare domain. So, Irina, the floor is yours. No, it's okay.
Hello everyone. So I'm going to present the Advanced Notebook. So what is Advanced Notebook? During the latest advancement today in machine learning, there's the need to have a tool, a framework for managing and developing machine learning systems, but to have a procedure which is can be easily integrated with other systems and easily developed to allow for rapid development of machine learning algorithms. We have integrated this advanced notebook system into healthcare related projects, iHelp, and also retention. And we are showing in this paper the architecture of this system and also the use cases that can be solved with this system. While the specifics of the configurations, the technical details will be presented in a follow-up paper. As an overview of the agenda, I will introduce the Advanced Notebook tool, describe the architecture, then I will talk about the specific use cases for the iHelp and retention project, and finally I will conclude and provide some future directions. As I already mentioned, there is the need for machine learning researchers and data analysts to have an easy tool to fastly develop machine learning models, and without having the need of special skills for development and operations. The advanced notebook tool allows this. It's simply to configure and has a smooth integration with other solutions. It can also be applied in different domains, not only the healthcare. For the moment, of course, we only demonstrate it for the healthcare domain. It can use any type of data, and different type of models can be included in the tool. Further, it will help maintain the machine learning research development and the experiments well organized, while at the same time will allow for the models to be used at any moment in time. The deployment is also flexible, so it can be deployed on a cloud infrastructure, but also locally on different locations due to privacy concerns. Going now to the architecture, the tool is composed of three main modules. The data reader, which accesses the data information from different sources according to the data provider on the right. And in the middle, the second module, the main core of the advanced notebook platform. And the third module, which is the model provider, which presents the results of the machine learning model to the knowledge display. Going step by step to each model, I will describe now. So for the data reader, I mentioned that it accesses the data and ingests the data to the machine learning model. Next, for the advanced notebook, it has also three subcomponents: MLflow, Jupyter Notebook, and the database. MLflow is used to manage the models, and also to store the trained models, serialize them into pickle files, and have them accessible for further use. And the database, which is the main model repository for storing the models along with the metadata. And the final module is the model provider, which accesses the model which were already trained within the main core, and accesses this, expose this as REST API to the knowledge display, which can be a third party with the aim to showcase the results of the prediction to the end user. And here there's a lot of flexibility. They can present the results in a nice graphical format for the end user. The modules are stored in Docker containers, and this facilitates an easy development, fostering fast implementation in different projects. When we think about machine learning process, we can, for example, divide into several steps each activity that is required for developing a machine learning model. First, it's important to initiate the connection between the data provider and the main core of the advanced notebook in order to insert the data into the system. Secondly, transform this data in order to make it in a tabular format to be ready for the machine learning model. The third step would be to the actual training of the model, creating the model, storing the model, which can be created in a separate notebook using the Jupyter notebooks. The next step, the fourth step, would be the validation procedure of the models, where different data is used to validate the system and compare the results using performance metrics, and also compare different models to improve performance. The next step would be the testing the model, and this can also be implemented in a separate notebook, and the final resulted model will be exposed as a REST API, and the results of the prediction analyzed further by third parties. With this in mind, we have applied the tool for the two projects. For the iHelp, the aim is to early detect pancreatic cancer. And here, the advanced notebook was deployed on a central cloud infrastructure. And during the next phase is planned to be deployed also on-premise for different locations due to the privacy concerns regarding data. Separately, for the retention project, the aim is to improve clinical management of chronic heart failure patients. And here, advanced notebook has been deployed. The testing part of a model has been deployed on premise, but the training has been deployed globally. So here, the two sites collaborate. The training is global, and the testing is performed at each clinical site. While the two projects are in the process of gathering data, we have exemplified these two use cases with some similar data we could find for the moment using on publicly available from Kaggle, for example, to showcase the functionality of the model. So not only the integration, but also the functionality that we can support for developing machine learning models. For example, for the iHelp use case, we use Kaggle data related to urinary biomarkers to predict the diagnostic of chronic pancreatitis or pancreatic adenocarcinoma. And on the graphic, on the image to the right, you can see the urinary biomarkers presented as a scatter plot where the data has been already normalized from 0 to 1. And it represents data from patients aged between 25 and 90 years old. This data is sparse and also scarce, so it has also many gaps and it's small. And for this, we have used an SVM model. However, I don't know if you can see much, but the accuracy is acceptable. It's around 80%. But of course, it's not enough for a valid machine learning model. But this can be fine-tuned later on. And this relies on the expertise of the machine learning researcher. Having this in mind, we have followed the same procedure with the retention project, where we used Kaggle data representing lab values for predicting heart failure mortality. For example, as you can see in the graph, we have ejection fraction with dark blue, sodium values with orange, creatinine with gray, platelets with yellow, and CPK creatinine phosphokinase with light blue. Again, data normalized from 0 to 1, and for patients aged from 40 to 95 years old. This data is also small, and we used the gradient boosting machine to predict heart failure mortality. We reached a very good accuracy, also comparable with the literature, up to 80%. And in order to have a deeper understanding on the model decision, we Advanced Notebook offers the offers the possibility to also integrate explainable measures. And for this, we have used, for example, the SHAP technique, where we could observe that creatinine, ejection fraction, and age, the blue bars on top, influence more the prediction. This would be summing up the simple examples of how the tool can be used. And it facilitates the model creation, storage, tracking, and deployment to all the stages of the machine learning development. It's an iterable solution that can speed up the machine learning development. It was applied on different infrastructures, accessing different type of data and resources, and it provides us the ways also to further enhancements. For example, it will be nice to have, especially since we are discussing about non-technical users, it will be nice to have a user-friendly interface to support the users in every step when developing a machine learning model. Next, since we, for the moment, only played around with simple data, the next step would be to adapt and test the possibility with larger data and even more complex, for example, using genomic data, imaging data, with combination with electronic health records. Expand also these investigations into other domains to improve the tool reliability. And since we have observed that the steps of the machine learning model could be separated into different locations, as it was the case for retention, the idea would be also to incorporate federated learning into the advanced notebook tool, meaning training the model on different locations and then combine the knowledge gathered from the different models and accumulate them in a global site. Thank you very much for your attention, and looking forward to your questions.
Thank you very much, Irina, for your great presentation of the overall advanced notebook. Any questions for Irina as concerns? Yes, please. Let's start from yes. We do not want to share.